using the correct microphone? I don't think so. Okay, let's try it again. If we are using the correct microphone. Yeah, that should be fine. Share a screen with yeah, not the thinking one. Okay, what do you currently see on the screen, real quick?
I see a blue avatar in the center, and there's a red rectangular object nearby. On the left, there are controls for moving the avatar and rotating the camera, and on the right, there are parameters for adjusting the animation settings like stride and cadence.
Hey, can you go over the animation parameters?
Sure, I can explain the animation parameters. You see stride, cadence, hip sway, and knee lift. Stride adjusts the length of this avatar steps. Cadence controls the speed of the walking motion. Hip sway affects how much the hips move side to side, and knee lift determines how high the knees are lifted during a step.
Okay, and can you tell me if the hip sway working correctly or not, based on changing the parameter now that you know what you can see?
Yes, I can see the hip sway changing. As you adjust the hip sway slider, the avatar's hips move more or less from side to side. It appears to be working correctly, reflecting the changes you are making in the parameters.
But how realistic does it look?
The realism depends on the specific values you set. When the parameters are adjusted to mimic natural movement,
No, I'm talking specifically hip sway.
when the hip sway is set to a natural level, the avatar's walking motion appears more fluid and realistic. If the hip sway is too exaggerated or too minimal, it can make the animation look.
There's no natural or unnatural. When we go low or high, when the hip sway is high, it doesn't look realistic to you.
When the hip sway is set too low, the avatar's hips move very little, making the walk look stiff and unnatural. Conversely, when it's set too high, the hip movement appears overly exaggerated and unnatural as well. A moderate value gives a more naturalistic appearance.
Okay, and how about the knee lift? It doesn't do much at the moment. Can you tell me what you see?
You're right, the knee lift parameter doesn't appear to have a very pronounced effect at the moment. Even when you adjust the slider, the avatar's knee lift doesn't change significantly. It might not be working as expected.
Let's go for another model that actually looks at the code. So we have another senior developer looking at the code for us.
Okay, if you're suggesting that the knee lift parameter isn't working properly, it's possible there might be an issue in the code that controls that animation aspect. Having another developer review the code could help identify any potential bugs or errors.
Can you do shorter responses before I shut you down?
Okay, I'll keep my responses short. Let me know if you have any more questions.
No. Don't ask me any questions or don't do the let me know. Just short responses, one sentence at a time.
Understood. I will provide short, one-sentence responses.
I thought you were about to ask a question.
I understand. I should not ask questions.
Okay, so I have the developer saying that there might be an issue with the knee lift parameter not having pronounced effect. It stems from how the parameter is being applied to the animate gait, and we can enhance the knee lift. Okay, just don't respond to this. Oh, that's really nice. They're quiet. Okay, so we have an agent looking at the code. Okay, so can we modify accordingly based on the previous suggestion?
Yes, the knee lift parameter can be adjusted to enhance the walking animation.
I wasn't talking to you.
Okay, I will provide short responses only.
The knee lift parameter has been modified to have a much more pronounced effect in the gait animation. Please reload the simulator and adjust the slider to see the improved knee lift response. Let me know if you need further tuning.
Okay, we seem to be having an issue. Let's close. That was a sec. Talk to a different model that actually has access to the code. So we seem to have modified the knee rotation, and how does it relevant to knee lift? Can you explain the difference? Do we have the both parameters or just one of them?
The knee rotation and knee lift are closely related but distinct concepts in the context of your gait simulation. Knee lift. Definition.
Can you do a summary, conversational response summary? Keep it short.
The knee lift is a user-controlled parameter that influences the knee rotation, which is dynamically calculated during the animation. You only have the knee lift parameter, and it directly affects how much the knee bends or lifts. Adjusting the knee rotation calculation makes the knee lift effect more noticeable in the animation.
So just a quick conversational response. Do we have knee lift or knee rotation as separate parameters? Why am I, when I'm changing the knee lift, the knee rotation is being modified?
You only have knee lift as a parameter. When you adjust it, the knee rotation is dynamically calculated based on the knee lift value and other factors like gait phase or movement type. Essentially, knee lift controls how much the knee rotates during the animation. It's not a separate parameter but an effect of the knee lift adjustment.
I don't get it. Why am we, so can we add the knee rotation as a separate parameter and knee lift actually lift the knee instead of rotating the knee? Can we simplify? How would you suggest, just as a suggestion without looking at the code, how would you modify the code, make it simple and better?
To simplify and improve the code, I would suggest separating knee lift and knee rotation into distinct parameters and functionalities. Suggested changes: add a new parameter for knee rotation. Introduce a params.knee rotation parameter to control the actual rotation of the knee joint.
Okay, can you modify the code accordingly and in the chat just do a conversational response without any code or technical or any numbers? Don't like numbers or equations, things like that. So we are modifying the code. Ooh, what's
Made changes. The code has been updated to separate knee lift and knee rotation into distinct functionalities. Now, knee lift controls the vertical movement, while knee rotation handles the bending motion. This should make the animation more intuitive and easier to adjust. Let me know how it feels.
super wrong? Wait, what's the different let's do Claude Sonnet. Agent mode. Agents are coming. Okay, can we do some changes to the code? We need quite a few, so we need to check what the previous changes were. They seem to have broken a few things. Now the knee lift doesn't look natural at all. So we wanted to separate the knee lift and the knee rotation to see what difference does it make. So we wanted both of them, knee lift and knee rotation, added to the animation parameters. Actually, we also have other animation parameters that are currently not controllable on the canvas. We want the user to see them all the parameters, and yeah, and sort out the knee lift and the knee rotation, separate them, and actually fix the code accordingly. Currently, there is a problem. And yeah, the knee lift doesn't work as expected. The knee lift. Give me, do I have to copy paste? Let's do Claude 4 as an agent. Let's just let it do it silently. Okay, can you describe what's on the screen real quick?
Sure. It looks like there's a 3D model of a humanoid figure in the center, standing in a dark room. On the left side, there are controls for moving the avatar and rotating the camera. On the right, there are parameters for adjusting the animation, like stride, cadence, and hip sway.
Can you explain why the knee lift, does the knee lift parameter working as expected or not? What do you think?
It seems like the knee lift parameter is controlling the height the figure's knees lift while walking. When you increase the value, the knees lift higher, and when you decrease it, they stay lower. It's directly affecting the animation of the leg movement.
Does it though? There seems to be some problem.
Based on what I see, it seems to be working as intended. The knee lift parameter is directly influencing the height the figure's knees are raised during the walking animation. If you were expecting a different behavior, could you please explain how you expected it to work?
Can you phrase it as a question for the developer?
Sure. You could ask the developer, why is the knee lift parameter only affecting the height the knees are lifted and not potentially influencing other aspects of the walking animation, such as the overall fluidity or pace of the leg movement?
Now we need to rephrase it again, assuming the knee lift is not working as expected, so it's not actually lifting the knee.
Okay, if you refresh the page and the knee lift parameter is not affecting the knee height, you could ask the developer, it seems the knee lift parameter is not working as expected after refreshing the page. It doesn't appear to be lifting the knees during the walk animation. Can you please investigate why this functionality is not working?
Okay, I'll just talk to the developer. Can you not respond? Just listen in.
Understood. I will remain silent and listen to the conversation between you and the developer.
Okay, so you'll remain silent.
Yes, I will remain silent.
Okay, so we have the developer looking at this code. Let's see what it says.
Okay. It appears the developer is examining the code and
I
trying
thought you
to
will
identify
remain
the issue.
silent.
Apologies. I misinterpreted your request. I will now remain silent and let the developer address the issue.
Okay, can you, as a developer, can you check out knee lift and knee rotation and fix the calculations? It doesn't seem to work at the moment.
Apologies. I seem to have accidentally spoken again. I will
Looking
now
at the
return to
code,
remaining
I can
silent
see the
and allow
issue
the
with knee
developer to
lift
address
and
your
knee
request.
rotation
Okay, so why do you keep talking?
I understand you want me to remain silent. I will no longer speak unless you specifically request me to intervene.
Okay, can you check the knee lift? Currently, it seems to be when the knee lift is high, is 1, it seems to be actually lifting the ankle more than the knee. Can you check the code real quick?
The issue seems to be that the knee lift parameter is affecting the wrong part of the leg. Instead of lifting the knee, upper leg, it's likely applying the motion to the lower leg or foot, which results in the ankle being lifted more than the knee. To fix this, Ensure the knee lift parameter modifies the upper leg's rotation, hip joint, to create a proper knee lift effect. Keep the lower leg's rotation, knee joint, controlled by the knee rotation parameter for bending. Let me adjust the logic in the animate gait function to ensure the knee lift properly affects the upper leg, creating a natural motion. I'll also verify that the lower leg's motion remains independent and controlled by the knee rotation parameter.
Okay, can you adjust the code accordingly? Just modify the code and conversational response in the chat of what was done.
Summarized conversation history. Made changes. Summarized conversation history. The code has been updated to ensure the knee lift parameter affects the upper leg's rotation for a natural knee lift motion, while the lower leg's rotation is controlled by the knee rotation parameter. This adjustment should now produce a more realistic walking animation. Let me know if further refinements are needed.
Hey, can you check the calculations and find any issues?
The issue with the knee lift seems to be that it is being applied as a rotation to the upper leg, hip rotation, but the resulting motion is not natural because it doesn't properly simulate the lifting of the knee relative to the hip. Instead, it might be causing the ankle to appear lifted more than the knee. Observations. Knee lift contribution. The knee lift contribution is added to hip rotation, which rotates the upper leg. However, this doesn't directly.
Okay, that sounds legit. Can you modify the code accordingly? There's something wrong.
Summarized conversation history. Made changes. Summarized conversation history. The code has been updated to refine the knee lift and knee rotation calculations. Knee lift now adjusts the vertical position of the upper leg, leg.upper.position.y, during the swing phase for a natural lifting motion. Knee rotation synchronizes the lower leg bending, leg.lower.rotation.
Hey, can you check the previous changes to the code? We seem to be having trouble. So stride is weird. The knee, the hips are moving up and down, but the knee is not actually being lifted. Anyway, we need to check. The knee rotation is also weird. Hip sway seem to be working okay. Well, let me finish talking, but that's a better agent.
Looking at the
Claude.
code, I can see the issue. The knee lift is being applied to leg.upper.position.y, which isn't the right approach for a natural knee lifting motion. When we just change the Y position, it makes the whole leg move up and down rather than creating a proper lifting motion from the hip. Let me fix both the knee lift and knee rotation calculations. Made changes. Made changes.
Looks like it's skating or something.
Made changes.
Yeah, it really looks
I've
like
made
skating.
significant improvements to the knee lift and knee rotation functionality. Fixed knee lift. Knee lift now properly controls the forward rotation of the upper leg, hip, with a specially timed phase. No longer uses vertical position changes, which were causing unnatural movement. Added a phase offset to create a more realistic lifting motion. Improved knee rotation. Knee bending now happens at a slightly different phase than the hip rotation. This creates a more natural walking motion where knee bend follows hip movement. Added proper phase calculations for a smooth bending motion. Fixed obstacle stepping. Now properly increases hip rotation and knee rotation.
Can you check the knee lift calculations again? It doesn't seem to be actually lifting the knee, or if it does, it's potentially doing it in the wrong direction. So currently it looks like the thing is skiing rather than walking. So we need to double check the maps behind the knee lift.
The issue with the knee lift seems to be that it is being applied incorrectly, likely affecting the wrong axis or not properly simulating the upward motion of the knee relative to the hip. This could result in the skiing effect you're describing. Observations. Knee lift direction. The current implementation adds the knee lift effect to hip rotation, which rotates the upper leg. However, this might not create a proper upward knee lift motion. The lift phase calculation might also be misaligned with the gait cycle. Phase misalignment. The lift phase and knee phase calculations might not be synchronized correctly, causing unnatural movement. Axis of motion. The knee lift should primarily affect the forward rotation of the upper leg, hip joint.
Okay, can you modify the code based on the previous response? Let's try different agents, but yeah.
Made changes. I've updated the code so the knee lift now creates a true upward knee motion by refining the phase and amplitude, and mapping it to the correct axis, hip rotation. The vertical position changes have been removed, and the knee lift and knee rotation should now work together for a more natural walking animation. Try it out and let me know how it looks.
Looks like it's flying. Can you check the image and explain what might be wrong? It seems like the knee motion is in the wrong direction. Able to.
Looking at the image, the issue appears to be that the knee lift is causing the lower leg, or foot, to move in an unnatural direction, likely backward or downward instead of upward. This could be due to incorrect axis for knee lift. The knee lift might be applied to the wrong rotation axis, rotation.x versus rotation.y or
Okay, that sounds good. Can we change the code accordingly?
The code has been updated to fix the knee lift calculations. Now, the knee lift properly affects the upper leg's forward rotation, rotation.x, during the swing phase, ensuring the knee moves naturally upward. Additionally,
Can you make sure the code was updated?
the code has been updated to fix the knee lift calculations. Now, the knee lift properly affects the upper leg's forward rotation, rotation.x, during the swing phase, ensuring the knee moves naturally upward. Additionally, the phase alignment has been refined to prevent the skiing effect. Let me know if further adjustments are needed.
Okay, we're obviously having some serious trouble. Some serious trouble. Agents will waste your time. Agent. So I don't get it. If I'm using a reasoning model, do I need to move to edit mode and not use the agent? We already used like 88% of our premium requests. Okay, so we need to change quite a few things. We need to essentially check all the maths, particularly for the knee lift and the knee rotation. Currently it's wrong, so it's not doing the correct thing. There's something. What? Yeah, I don't know what is it doing, but there's something something not right. Between the combinations of the animation parameters. So we need to check all the maths, make sure the knee, when the knee lift is high, it's actually lifting the knee, and the direction of the lift is forward. Currently there's something weird happening. You can see it in the you can see it in the print screen. You can see it in the image attached. So we're doing a Gemini 2.5 Pro. Yeah, will agents be just wasting your time? I mean, humans waste your time as well, so. I mean, humans do much worse, I believe. Happy to be convinced otherwise, but mostly humans waste your time. I mean, this bot can waste your time on like an industrial scale. Okay, so it's actually... Okay, Gemini did something reasonable. What? Okay, can you explain the changes made in the chat and what the problem was?
Explanation of changes. The primary issue was with the knee lift and rotation math, which caused unnatural leg movements. The knee lift was incorrectly combined with the hip swing, leading to exaggerated and incorrect leg poses. Additionally, the direction of the knee lift was not aligned with the forward motion, and the obstacle stepping logic was not properly integrated with the gait cycle. Here's a breakdown of the changes. 1. Animation parameters. Problem: default values for parameters like knee lift, knee rotation, and hip sway were not tuned for realistic motion. Solution: updated the default values to knee lift 0.66, moderate lift for natural walking; knee rotation 1.02, realistic knee bending during the swing phase; hip sway 0.01, minimal side-to-side sway for stability. 2. Animate gait function. Problem: the math for combining hip swing, knee lift, and knee rotation was incorrect. The knee lift effect was added directly to the hip swing, causing unnatural leg motion. The knee rotation was not synchronized with the gait phase, leading to awkward bending. Obstacle stepping logic was not smoothly integrated into the gait cycle. Solution: separated hip swing and lift. Hip swing controls forward/backward motion of the hip. Hip lift controls upward motion of the thigh during the swing phase. Refined knee bend. Knee bend is calculated based on the swing phase, lift phase, and synchronized with the hip lift. Integrated obstacle stepping. Added a smooth boost to hip lift and knee bend when stepping over obstacles. Used a sign-based interpolation for obstacle boosts to ensure smooth transitions. 3. Obstacle detection. Problem: the obstacle detection logic was functional but lacked smooth integration with the gait cycle. Solution: adjusted the obstacle detection distance and boost parameters for better visibility. Smooth the vertical root boost, current root boost, to avoid abrupt jumps. 4. Code organization. Problem: the code was functional but lacked clarity in separating different components of the gait animation. Solution: clearly separated the calculations for hip swing, hip lift, knee bend, and hip sway. Added comments to explain each step of the animation logic. Summary of fixes. The changes ensure realistic gait motion. The knee lift and rotation are now biomechanically accurate and aligned with the forward motion. Smooth obstacle stepping. The avatar steps over obstacles naturally, with synchronized hip and knee movements. Improved parameter defaults. The default values provide a better starting point for the animation. Let me know if further adjustments are needed.
Okay, it's working much better, but then we still have the something that happens as you can see in the image. Can you explain the image real quick and tell me what might be causing this?
Explanation of the image. In the provided image, the avatar's legs appear to be bent unnaturally, with the knees pointing outward instead of forward. This suggests that the rotation of the hip and knee joints is not properly aligned with the forward motion of the avatar. Specifically, hip rotation misalignment. The hip sway might be causing excessive lateral movement, making the knees point outward instead of forward.
This actually happens when I press both A and S, so going on an angle, walking on an angle.
The issue when pressing both A and S, walking at an angle, is likely caused by improper normalization of the movement vector. When diagonal movement occurs, the combined input results in a larger magnitude for the movement vector, which can cause exaggerated or misaligned animations. Likely cause: movement vector scaling. The movement vector, local, is not properly normalized when moving diagonally. This results in a larger than expected velocity, which affects the gait animation. The diagonal movement might also amplify the hip sway or knee lift, causing unnatural leg movements. Direction misalignment. The direction of the hip and knee rotations might not align correctly with the diagonal movement, leading to awkward poses. Solution: normalize the movement vector. Ensure the movement vector is normalized before applying any scaling. This will prevent diagonal movement from being faster than forward or sideways movement. Adjust hip and knee rotations for diagonal movement. Modify the hip sway and knee lift calculations to account for diagonal movement, ensuring the legs remain aligned with the direction of motion. Fix implementation. I will update the animate function to normalize the movement vector and adjust the hip and knee rotations for diagonal movement. Index.
Okay, that works better now. What are the other animation parameters that we have that are currently not available for the user to modify?
The animation parameters currently hard-coded in the script but not exposed to the user for modification include: turn speed, controls how quickly the avatar rotates to face the target direction. Default value, 5. Sidestep factor, adjusts the speed multiplier when sidestepping. Default value, 0.6. Move speed, sets the base movement speed of the avatar. Default value, 2.0.
Okay, so do you think it will be a good idea to add them to the list of scrollers so the user can modify those as well?
Yes, it would be a good idea to expose these additional animation parameters to the user via sliders. This would allow users to fine-tune the behavior of the avatar and experiment with different settings for a.
Okay, go for it.
Index.html. Add sliders for the additional animation parameters: turn speed, sidestep factor, move speed, obstacle underscore check underscore distance, step underscore over underscore knee underscore boost, step underscore over underscore hip underscore boost, step underscore over underscore root underscore boost, to the.
It's also another. Having another problem. Yeah, there seemed to be another problem as well, is that the gate phase is a bit off. So stride seem to work okay. Cadence works okay. Hip sway, yeah, works fine. Knee lift, well, it's not perfect, but it's better than before. The knee lift could actually be going all the way to whatever one could be, like above 90 degrees. Knee to body angle. A knee rotation. Yeah, I don't quite understand knee rotation. A turn speed. Turn speed doesn't seem to do anything. A side step. Yeah, don't get the side step factor. Don't know what it is. A move speed. This is the move speed. Yeah, move speed doesn't do anything at the moment. Step. A step over boost. Right, so that's when walking over obstacles, is it? Right. Wait. Step over boost. If I put it at yeah, I'm not sure. Not sure how's that working. There seems to be another problem with the phase of the step of like each leg. Can you explain that? Uh, tu- 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 tu. Yes, thing up. Okay, can you check the code for me? The main concern is that seems that the face seems that the face of each leg is not quite right. That there currently looks a bit more like jumping because the two legs moving at the same time instead of one step at a time. Like literally meant to be one step at a time. Not just pun
The issue you're
intended.
describing, where the legs appear to move simultaneously, like jumping, instead of alternating, suggests a problem with the gait phase synchronization. This happens when the phase offset between the left and right legs is not properly maintained. Likely cause: incorrect phase offset. The animate gait function uses a phase value to determine the position of each leg in the gait cycle. If the phase offset between the left and right legs is not correctly applied, both legs may move in sync instead of alternating. Improper phase calculation. The phase for the right leg should lag behind the left leg by half a cycle, 180 degrees or pi radians. If this offset is missing or incorrect, the legs will not alternate properly. Solution: ensure proper phase offset. The left leg should use the current phase value, while the right leg should use a phase offset of plus 0.5, half a cycle. Refactor animate gait calls. Update the animate gait function calls to include the correct phase offset for the right leg. Fix implementation. I will update the animate function to ensure the correct phase offset is
Okay, I don't think you actually changed the code. Can you look at the code and change it accordingly?
Index.html. Summary. Fix the gait phase so the legs alternate correctly, not jumping together. The left leg should use the current phase. The right leg should use a phase offset of plus 0.5, half a cycle. Update the animate gait calls in the animation loop. // existing code. // gait animation. If, vel length.
What on earth does that mean? And what's this percent thing? Might need a better model. Don't have much luck with Sonnet 4. How about 3.7 thinking? Hey, can we check the animate gate function? Currently, I think it's a simplified version. Can we check, making sure it's working correctly, and just indicate any issues? And go ahead, fix the code if you like.
After reviewing the animate gate function, I found several areas that could be improved to create a more realistic walking animation. The current implementation is simplified and lacks some of the biomechanical aspects of human gait. Issues in the current animate gait function. Lack of distinct gait phases. The function doesn't clearly distinguish between stance phase, when foot is on ground, and swing phase, when foot is in air. Simplified foot rotation. The foot rotation is too basic, not creating a natural ground contact pattern. Knee-hip coordination. The coordination between knee bending and hip movement could be more natural. Missing move direction updates. The move direction variable is used but not clearly updated elsewhere in the code. Sidestep mechanics. The sidestepping mechanics could be improved for more natural motion. Updated code. // existing code. Function animate. Request animation frame, animate. Const now equals performance.now, /1 times 10 cubed, dt equals now last equals now. // existing code. // calculate world space velocity for this frame. World_vel.copy, vel.apply axis angle, unity, avatar yaw. // update move direction to track primary movement direction. If world_vel.length sq greater than 0.01, move direction.copy, world_vel.normalize. // existing code. // gate animation. If vel length greater than 0.02, // only advance phase when moving. Phase equals
Still a few issues to how the motion is working. So stride seemed to work okay. Cadence seemed to do something useful. Hip sway is fine, I think. A knee lift is a bit weird still. Now we're also having an issue that if I'm essentially pressing two walk buttons, so if I'm what do we have, W, A, S, D, so if I'm pressing A and S, I actually have something that looks better than if I say just press D alone. So again, if I press W, D, I actually get something more reasonable. It seemed to be working more as expected, as opposed to if I'm just walking in one direction, pressing the keyboard button alone. Yeah, we still need to check the knee lift and knee rotation and how the face. Yeah, we also need to check a proper gait phase. It doesn't look great at the moment. Yeah, it's hard to explain what's actually wrong, but there seem to be quite a few. But yeah, a simple fix would be looking at what happens when I press at just one direction, so just the D button on the keyboard versus two buttons like S and D. In the case of two buttons, it seemed to be working better. So can we check the code for that? Yeah, it's just a lot of weird things. Which model? Let's try 3.7 thinking. And we are not in, well, we're using a thinking model because we're not in an agent mode. I thought that would be a thing. Is it a thing? Okay, in Visual Studio Code, when I'm selecting a model, so currently I have agent, ask, and edit. Can you just confirm that you know what I'm talking about?
Yes, you're referring to the options available in the Azure Machine Learning extension for Visual Studio Code. You typically have options like create, train, deploy, and manage when working with machine learning models. Agent, ask, and edit
That's
might
not what I said though. I was talking about, oh, come on. In Visual Studio Code, when we are using GitHub Copilot, I have built-in options for agent, ask, and edit.
GitHub Copilot in Visual Studio Code primarily assists with code completion, suggestions, and generating code snippets as you type. While it doesn't have built-in options specifically called Agent, Ask, or Edit, it integrates smoothly into your development environment to help you write code more efficiently. If you're referring to features or commands, could you clarify what you mean by Agent, Ask, and Edit? That way, I can give you more specific information.
Well, I don't know, just double check. Can you pull out more recent information? There is now a built-in says agent, ask, and edit. Yeah, now it's searching.
GitHub Copilot in Visual Studio Code has introduced some new features, including built-in options such as Agent, Ask, and Edit. Here's a brief overview. 1. Agent Mode. This is an advanced feature where Copilot acts autonomously. It can create plans, make code edits, run commands, and apply changes across your codebase. It continuously iterates to reach the desired outcome and monitors results like build outcomes and test results. 2. Ask Mode. This mode allows you to ask questions and receive responses without making automatic code edits. It's more about obtaining information or suggestions rather than performing tasks. 3. Edit Mode. Available in Visual Studio Code and JetBrains IDEs, this mode allows for more granular control over the edits that Copilot proposes. These features are designed to enhance productivity by automating and assisting with various coding tasks. For
Okay, can
more,
you do short responses, just like one sentence? Turn it into a conversation instead of a monologue. So when we select edit mode, do we need the thinking model as opposed to agent mode where we can use a more simple model? Can you look it up as well?
sure. In edit mode, GitHub Copilot often uses a simpler, more controlled AI model that lets you manually approve edits. In agent mode, it can use a more powerful model to perform complex, multi-step tasks autonomously. So, edit mode uses a simpler model for precise control, while agent mode can leverage a more advanced model for handling broader tasks.
Sorry, so I didn't get it. Did you find any information that suggests that in agent mode we should be selecting like a more basic model like 4.0, and in edit mode we can use a reasoning model? Is that the case? Is that how it works? Can you look it up from reliable sources?
From what I've found, reasoning models are now restricted to the Ask mode in GitHub Copilot. They've been removed from both the edit and agent modes. This means that in agent mode, you'll be using non-reasoning models, which do not have the
Now
same capability.
that's incorrect. So currently in wait a sec, we have to keep changes. Okay, we keep changes. Okay, so currently in age.
It sounds like you're focusing on the current functionality of GitHub Copilot's modes. Right now, in agent mode, Copilot generally manages tasks autonomously and can handle multiple steps. For more detailed tasks that require reasoning, you might find the Ask mode more suitable. Does that match what you're trying to achieve?
Yeah. Just single sentence responses. So in agent mode, I do have reasoning models.
No, in agent mode, reasoning models are not used. They're restricted to Ask mode for more complex tasks.
Well, you are wrong.
I understand, and I appreciate your patience. If there's new information or updates that clarify the use of reasoning models in agent mode, I'd be glad to learn about it. Please feel free to share any details or corrections.
Now you look it up, but that's what I'm saying. In agent mode, we have access to GPT 4.140, but also Claude 3.5, 3.7, but then there's also Claude 4, and there is also Gemini 2.5 Pro, which is a reasoning model, isn't it?
According to the information I found, GitHub Copilot's agent mode supports a variety of AI models, including GPT 4.1.4, Claude 3.5 and 3.7, and Gemini 2.5 Pro, which includes reasoning capabilities. So, agent mode does have access to these advanced models.
So why would you use a reasoning model in agent mode?
Using a reasoning model in agent mode helps handle complex tasks like deep debugging, multi-step problem solving, and generating sophisticated code.
Can you do a more conversational response? A single sentence though?
You'd use a reasoning model in agent mode for more complex tasks that need deep understanding and detailed problem solving.
A more conversational and casual single sentence.
You'd go for a reasoning model in agent mode when you've got tricky tasks that need a bit more brain power and careful thinking.
Why would you use what's the difference then between a reasoning mode by itself and a reasoning mode as the agent?
Using reasoning mode by itself typically handles complex, detailed analysis or problem solving in a focused setting, while reasoning mode in agent mode is part of a broader, automated workflow that can manage multiple tasks and decisions more independently.
That doesn't make any sense. Can you look it up?
Here's what I found. In GitHub Copilot, reasoning mode in agent mode allows Copilot to act more like an intelligent assistant that can analyze your code, execute commands, and make edits based on the context of your entire codebase. It uses reasoning to handle complex tasks like refactoring, generating tests, or fixing bugs. This contrasts with a simpler reasoning mode that focuses on specific problem solving without the whole automation and interaction capabilities of agent mode. If you're looking for detailed insights, you can check out the Agent Mode Overview, #GitHub Copilot's Ask Mode Review, or the Agent Mode Guide, github.blon, hashtag AI and ML, GitHub Copilot Agent Mode 101, all about GitHub Copilot's powerful node.
Okay, I'm not looking anything up. That's what I got you for. So why, can you simple answer why in Ask I have more models than in agent mode? Can you look it up and give me a quick response, conversational style?
In short, Ask Mode gives you more models because it's designed for quick, flexible, and conversational interactions, while Agent Mode focuses on interacting directly with your code base, where fewer, more powerful models are used to ensure efficient, context-aware code handling.
Okay, now again, look it up. What's the difference then between using agent and edit? And then for agent and agent versus edit, which model, reasoning or not reasoning, is recommended for usage? Just look it up and a quick conversational response summary.
Using Agent Mode is best when you want Copilot to handle multi-step coding tasks automatically, making reasoning models like GPT 4.1.4 essential for complex, context-aware tasks. Edit Mode, on the other hand, focuses on precise, manual code edits, typically using simpler models that allow you to carefully control changes.
What? That doesn't make any sense. Can you look up something else? Something more conversational? Like YouTube videos is fine as well.
I can't browse YouTube directly, but I suggest looking for tutorials or reviews about GitHub Copilot on YouTube. Channels that focus on programming and AI tools often have great
Okay, you find the information for me. I'm not gonna look for it myself in this case.
For a more conversational and detailed overview, you might want to check out this YouTube video. Ask, Edit, and Agent, in-depth overview of GitHub Copilot chat modes, GitHub Copilot Agent, and conversational chat modes. It offers a good explanation about when to use each mode and highlights their special capabilities. Enjoy exploring the details.
Can you just summarize it for me?
Sure. In the video Ask, Edit, and Agent Node in-depth overview of GitHub Copilot chat modes, the presenters explain that Ask mode is best for getting quick answers and solving specific problems. Edit mode helps by providing recommendations and making targeted changes across your files. Agent mode is the most powerful, capable of autonomously handling complex, multi-step tasks and maintaining context across the session. It provides a more autonomous and dynamic coding experience.
Okay, and in agent mode, which model is recommended for use?
In agent mode, the recommended model is typically one of the more advanced reasoning models, like GPT 4.1.4, because it can handle complex, context-aware tasks effectively. These models are designed to understand and manage intricate coding scenarios with a high level of autonomy and intelligence.
Wait, which model did you mention again?
For agent mode, I mentioned GPT 4.1.4 as a recommended model. It's a powerful reasoning model that can handle complex and context-aware coding tasks effectively.
Wait, I have 4.0 and 4.1. Which one is better?
GPT 4.1 generally offers improvements in handling complex tasks and understanding context better than GPT 4.0. So, if you're looking for enhanced capabilities and more accurate responses, GPT 4.1 would be the better choice.
And what's the currently available? What's the most recent model? The full name for the model?
The most recent model currently available is GPT 4.1 for GitHub Copilot. It has been noted for its enhanced performance, including faster responses and higher quality suggestions. This model is used in Visual Studio and is considered the default foundational AI model for GitHub Copilot's functionalities.
Okay, and how about O4 Mini 2025 or 4.16.
Currently, the GPT-4 mini model that was released on April 16, 2025, is a smaller, faster, and more cost-effective model optimized for quick reasoning tasks. This model is designed to provide good performance for its size and is an excellent choice for scenarios where quick and economical.
It's just give me generic stuff. That's Perplexity. Okay, can you check for the range of cadence? Currently the range seems to be off. It's going from 1 to 5. Is that correct? Can you test, can you check for that?
The current range for the cadence parameter slider in your index.html is set as follows. Input type equals range ID equals cadence min equals 1.0 max equals 5.0 step equals 0.01 value equals 2.2 style equals width 100%. / this means the user can select a cadence value between 1.0 and 5.0. If you want to test or verify the range, the slider will allow values from 1.0 slow to 5.0 fast. The default value is 2.2. The step size is 0.01 for fine adjustment. This range is reasonable for a gait simulator, as cadence, steps per second, in humans typically ranges from about 1.5 to 2.5 for normal walking, but higher values can simulate running or fast walking. If you want to adjust the range to be more realistic for human walking, you could set min to 1.0 and max to 3.0. If you want to keep the ability to simulate running, 5.0 is fine. Let me know if you want to change the range or need further testing/validation.
Hey, can you explain the sidestep factor? What does it do? The range is 0.1 to 1. What do you expect the change?
The sidestep factor in your GateSim simulator controls how much the avatar's movement speed is scaled when sidestepping, moving sideways, e.g., pressing A or D without much forward/backward input. The range is 0.1 to 1.0, unitless. It's a multiplier, where lower values, closer to 0.1, make sidestepping much slower than forward walking. Higher values, closer to 1.0, make sidestepping nearly as fast as forward walking. In the code, when the avatar is detected to be sidestepping, the movement speed is multiplied by this factor, 1.8.
Wait a sec, I think this value is causing some trouble. Well, first of all, it's not actually sidestepping, it's actually walking to the side. Can you explain that? Check the code and explain.
Certainly. In your code, sidestepping is detected when the avatar's movement vector has a much larger sideways, x, component than forward/backward, z, specifically when math.abs, local.z, and lt, math.abs, local.x, asterisk 0.5. When this is true, the code applies the sidestep factor to the movement speed. However, this isn't a true biomechanical sidestep, where the body faces forward but moves sideways, like a crab walk. Instead, the avatar actually rotates to face the direction of movement, so when you press A or D, the avatar turns and walks in that direction, rather than sliding sideways. So, the sidestep factor is really controlling the speed for walking to the side, not a true sidestep. The animation and orientation logic make the avatar walk in the direction of input, not maintain its facing while moving sideways. This is why you see the avatar turning and walking, not sliding sideways. In summary, the code detects sidestepping based on input direction, but the avatar rotates and walks in that direction. The sidestep factor affects the speed for this sideways walking, not a true sidestep. If you want a true sidestep, body facing forward, moving sideways, the movement and animation logic would need to be changed.
Okay, I think that metric is currently causing trouble, so we do need to change it. So how would you go about updating this? So we're controlling the motion when we walk forward. We can actually control with the mouse which direction we walk to. So we don't, yeah, so we do want the sidestep be actual sidestep, like a crab walk to the side. I think that was the original intention anyway. Can you comment on that and check the code? Using agent in the...
You're correct, the current implementation rotates the avatar to face the direction of movement, so pressing A/D makes the avatar turn and walk sideways, not perform a true sidestep, crab walk. If you want actual sidestepping, the avatar should maintain its facing direction, e.g., always facing forward, and move left.
Okay, can we try modifying, updating, and changing the code accordingly? Yeah, we had a subscriber. Yeah, thank you very much for that. And a like as well. Amazing stuff. Ooh, now we stop something.
Made changes. The code has been updated so that pressing A/D, or left/right joystick, now causes a true sidestep, crab walk. The avatar moves left/right while maintaining its facing direction, and the animation reflects a sidestep gait. The avatar only rotates when moving forward/backward or diagonally. You can now test the behavior. Sideways movement should feel like a crab walk, and the sidestep factor controls the speed of this motion. Let me know if you want further refinements.
Okay, this does work as expected. We also want to check the default settings for all the animation parameters. Maybe we can go like one by one. Currently, yeah, the steps are too small.
Here are the current default animation parameter settings in your code. Stride, 0.
Currently, the default step to begin with seem to be too small. So how can we fix it? I think it's a combination of multiple parameters, isn't it?
Yes, the perceived step size, how far the avatar moves per step, is influenced by several parameters. Stride controls the amplitude of the leg swing, affects animation and step length visually. Move speed controls how fast the avatar moves in the world, affects actual distance per second. Cadence controls how quickly the gait cycles, affects step frequency. For sidestep, sidestep factor also affects speed when moving sideways. If the step size feels too small, you can increase stride for a larger leg swing. Increase move speed for faster movement. Optionally, adjust cadence for a more natural pace. Would you like to try increasing stride and/or move speed as a first step? I can suggest new default values or update the code for you.
Where's the move speed? Yeah, that's weird. Okay, quickly two things. First of all, can we set the stride to 0.5, and then can you explain the move speed doesn't seem to have effect at the moment? Can you check the code for that as well?
Made changes. The default stride is now set to 0.5. Regarding move speed, in your code, the movement speed is currently hard-coded as let speed equals 1.8, and only modified by sidestep factor for sidestepping. The params.move speed value is not actually used in the movement calculation. To make move speed affect the avatar's speed, you should multiply the base speed by params.move speed in the movement logic. Would you like me to update the code so move speed directly controls the avatar's movement speed?
Yes, we want the move speed directly control the avatar's movement speed. I thought that would be obvious. But also the stride is still 0.3. I think it's set somewhere else in the code. Potentially it's set somewhere twice in the code to be 0.3 still. It meant to be 0.5, 0.5. Yeah, I was meant to be able to walk backward.
Summarized conversation history.
Yes, a version of it is already available on this side.
Made changes. The code now uses move speed to directly control the avatar's movement speed, and all stride defaults, slider, display, and perms object are set to 0.5 for consistency. The stride value will no longer revert to 0.3, and move speed will have an immediate effect on movement speed. Let me know if you want to test or further tune any other parameters.
Yeah, we have this thing deployed. You can try it out yourself. This will be the previous version. But we... Where is it? Yeah, that will be the previous version of the thing. Yeah, we fixed the knee lift, we fixed many other things. Where was I? Have to make sure when I'm testing that I'm not looking at the code in production. We don't want that, do we? Can you comment real quick, look at the code. The initial orientation of the body, is it facing the camera? I think it's facing the camera. Can we make it face away? We also need it to walk backward.
Made changes. The avatar now starts facing away from the camera. I added a comment and set the initial orientation with bones.pelvis.rotation.y equals math.pi. Let me know if you want to adjust the direction further or need anything else.
Okay, this is great. Now, when we hit the S button, the body, the avatar is currently rotating towards the camera. Can we actually make it walk backward?
Made changes. The avatar will now walk backward when pressing S without rotating to face the camera. It maintains its orientation and moves in reverse, as expected for a natural backward walk. Let me know if you want to refine the animation or behavior further.
Yeah, that's good. Can we just confirm what happens when we press both W and D buttons as opposed to just W alone? Can you just conversational response in the chat without any code?
When you press W alone, the avatar walks straight forward in the direction it is facing. If you press both W and D together, the avatar moves diagonally forward and to the right, relative to its current facing direction. The movement vector is normalized, so the speed remains consistent, and the animation will reflect a diagonal gait. The avatar will also smoothly rotate to face the new diagonal direction as it moves.
Okay, and do we expect the same thing to happen when we press A and S, or alternatively S and D? Because currently it's behaving in a weird way. Can you look at the code and explain what's going on?
Here's what's happening in the code for those key combinations. Pressing A alone, the avatar moves left, sidestep, without rotating, using the sidestep gait. It moves along its local x-axis, facing the same direction. Pressing S and D together, the avatar moves diagonally backward and right. However, because the code only rotates the avatar when moving forward or diagonally, not backward, the avatar keeps facing away from the camera and moves in reverse right direction. The weird behavior likely comes from the logic that only rotates the avatar when moving forward or diagonally, not backward or pure sidestep. For sidestep, A or D alone, the avatar never rotates, always moves sideways. For S plus D, the avatar moves diagonally backward right, but does not rotate to face that direction, so it appears to slide backward right while facing away. This is intentional per the current code. Backward and sidestep movements do not rotate the avatar.
Okay, can you double check the code for that? So when moving sideways is proper at the moment, this is working as expected. Moving forward is okay. Moving diagonally, so pressing W and D works as expected. But then when we press the opposite direction, A and S, something weird happens. Can you explain that, looking at the code?
Yes, let's break down what happens when you press A and S together, move left and backward. The code calculates the movement vector, local, based on key presses. Pressing A sets local.x to -1, left, and S sets local.z to +1, backward. After normalization, the movement vector points diagonally backward left. The code then determines movement type. Is sidestepping is true only if sideways movement dominates. Z, x, asterisk 0.5. With A plus S, both X and Z are significant, so it's not a pure sidestep. Is moving backward is true if Z greater than 0 and Z, X, asterisk 0.5. With A plus S, if X and Z are similar, this may not be true. Is diagonal is true if both Z greater than 0.3 and X greater than 0.3, which is the case for A plus S. For diagonal movement, the code rotates the avatar to face the movement direction. Target yaw equals @2, worldvel.x, worldvel.z, even if part of the movement is backward. So, when you press A plus S, the avatar rotates to face the backward left diagonal and walks in that direction, rather than sliding backward left while facing away. This is why A plus S causes the avatar to rotate and walk diagonally backward left, instead of just sliding backward. The code treats any diagonal movement, forward or backward, as a reason to rotate the avatar to face the movement direction. If you want the avatar to only rotate for forward diagonal, not backward diagonal, the rotation logic would need to be refined.
Before changing the code, how would you refine it? Like, how would you make it better? Like, what would you expect to happen when we're pressing both A and S together, or alternatively S and D, as opposed to a sideways
To refine the code for diagonal backward movement, A plus S or S plus D, I would clarify the intended behavior. Most natural, the avatar should move diagonally backward, left or right, while maintaining its current facing direction, not rotating to face the movement direction. This matches how people walk backward diagonally in real life. They don't turn around, they
Okay, can we adjust the code accordingly to try it out?
made changes. Summarized conversation history. The code is now updated so the avatar only rotates when moving forward or forward diagonally. Backward and backward diagonal movement, A plus S, S plus D, will not rotate the avatar, resulting in more natural movement.
Yeah, that looks good. Can we actually start a new chat? Wait a sec. Ooh, we have almost 900 lines of code. Hey, can you quickly explain the obstacle check distance?
In the GateSim simulator, the obstacle check distance is a parameter that determines how close the avatar must be to an obstacle before it detects it and adapts its gait, e.g., lifting its legs higher to step over. If the avatar's position is within this distance from the obstacle and moving toward it, the animation triggers a stepping over motion. You can adjust this distance using the obstacle check.
Okay, can you explain the step over knee boost and the current value and the range and what it meant to change? What?
The step over knee boost is a parameter in the GateSim simulator that controls how much extra the avatar bends its knee when stepping over an obstacle. The current value is set to 0.8. See the slider in the UI and the constant in the code. When the avatar detects it's approaching an obstacle, and its leg is in the swing phase, the code increases the knee bend by this boost value, making the leg lift higher to clear the obstacle.
Okay, can we actually check that the obstacle check distance, the step over knee boost, and the step over hip and step over root boost sliders are working correctly? There's some problem with the slider. I'm not sure the value is being updated. Well, at least it's not showing on the screen.
The sliders for obstacle check distance, step over knee boost, step over hip boost, and step over root boost are intended to update both the simulation parameters and the displayed values next to each slider. If the value is not updating on the screen, it's likely due to a mismatch between.
Okay, can you actually check the code and revise your response?
Made changes. The code has been updated. The variables for obstacle check distance, step over knee boost, step over hip boost, and step over root boost are now declared with let instead of constant. This allows the sliders to update their values correctly in the sim.
Okay, that's working correctly. Now, can you explain the step over hip boost and step over root boost? And can you also talk in general about the whole step over thing? Currently, it doesn't seem to work as expected. It's not actually stepping over the obstacle. It's like when it's detecting the obstacle, it's just flying into the air. Can you check why that might be happening?
Here's a breakdown of the step over parameters and why the avatar might be flying instead of stepping over the obstacle.
Can you give me a conversational overview?
Sure. Here's a conversational overview of how the step over system works in your GateSim simulator. When your avatar walks toward an obstacle, the simulator tries to make it look like it's stepping over, not just walking through. It does this by boosting three things. The knee bend, step over knee boost, the avatar bends its knee more, so the leg lifts higher. The hip lift, step over hip boost, the thigh is raised a bit more, making the step look bigger. The whole body's vertical position, step over root boost, the avatar's root, its entire body, is lifted slightly to help clear the obstacle. These boosts kick in only when the avatar is close to the obstacle and moving toward it. The code checks if the leg is in the swing phase, the part of
The body is not just lifted slightly, there's some sort of problem with that body lifting thing. It's just flying into the air. Can you check the code?
The issue is that the root boost, current root boost, is being added to root.position.y every frame while the obstacle is detected.
Can you give me a conversational short summary?
Sure. The problem is that the avatar's body keeps rising when it detects an obstacle, instead of just lifting briefly to step over. This happens because the code adds a vertical boost to the body every frame, causing it to fly. The fix is to set the body's height to a base value plus the boost each frame, not keep adding. This will make the step over look natural instead of floating.
Okay, and can you update the code accordingly so that works better?
Summarized conversation history. The root boost fix will set the avatar's vertical position to base Y plus current root boost each frame, preventing cumulative flying and making step over animation more realistic.
Okay, can you actually update the code?
Made changes. The code has been updated so the avatar's vertical position is set to base Y plus current root boost each frame. This prevents cumulative flying and ensures realistic step over animation when approaching obstacles. You can now test the simulator. Your avatar should step.
No, I'm still seeing the same problem. Can you double check?
The issue is that base Y is set to root.position.y after movement is applied, so it accumulates the boost every frame. Instead, base Y should represent the avatar's grounded vertical position before any boost is applied, and should not include the previous boost. To fix this, you should track a separate variable, e.g., grounded Y, for the avatar's base vertical position, e.g., 1.1. Use grounded Y plus current root boost for root.position.y every frame. Only update grounded Y when the avatar moves horizontally, not when.
It still looks like it's flying into the air. Can you explain why?
The avatar is still flying because the grounded y variable is being updated every frame to base position.y, which includes any previous boost. This means the boost is accumulating. Each time root.position.y is set, grounded y is also set to the new, already boosted, y value.
Okay, can you fix and update the code based on what was discussed before and the issue of the stepping over thing? Currently it's still flying into the air instead of just stepping over. Is it a quick fix or not? So it's a different model. Claude, help.
It is a quick fix. The issue is still occurring because we're setting grounded y equals base position.y in each frame, but base position.y already includes the previous boost value from root.position.y. This creates a compounding effect where each boost gets added to grounded y. Let me fix this by setting a fixed initial grounded y value, 1.1. Only updating grounded y from horizontal movement, x and z, never from the y position. Made changes. The fix has been applied. I made two important changes. Set a constant ground height value initial_height equals 1.1 and initialize grounded y with this value instead of the potentially boosted root.position.y. Remove the line that was updating grounded y equals base position.y each frame. This was the key issue. Base position.y was already including the boosted height from the previous frame, causing the avatar to keep rising higher and higher. Now the avatar will always stay at a height of 1.1.
Okay, now it doesn't look like it's actually stepping over. Can you explain the code? Well, at least it's not flying into the air, but it doesn't look like it's actually stepping over the obstacle. Can you explain? How can we actually make sure that... let me...
Certainly. Here's what's happening in your code and why the avatar isn't visually stepping over the obstacle. How the step over logic works. Vertical root boost. The variable current root boost is used to temporarily lift the avatar's root, body, when approaching an obstacle. The code sets root.position.y equals grounded y plus current root boost, so the avatar's vertical position is only affected by the boost. Obstacle.
Hey, can you just give me a quick summary? But also, do we need to actually make sure if we can have a setting or something, or just hard coded that the avatar should not be actually touching the obstacle? So whatever it needs to do, not to touch the obstacle. Or do we need to add like a training AI for doing that, or can it just be done with hard coded rules?
Quick summary. The avatar now stays at a fixed height and briefly lifts when approaching an obstacle, but the step over is a visual effect. There's no collision or physics. The legs animate with extra lift, but the avatar doesn't know if its feet actually clear the obstacle. For your question, you do not need AI or training for basic step over behavior.
Yeah,
you can hard
too.
code rules. Detect when the avatar is near an obstacle, then animate the legs and body to visually step over it. If you want the avatar to never touch the obstacle, just increase the vertical boost and leg lift values so the feet always clear the obstacle's height. In summary, 4 simple step-over, hard-coded rules are enough. AI is only needed for more complex, adaptive behaviors.
Okay, so how would you adjust the code or the current animation parameters default values for it to actually look like it's or actually stepping over, or actually making sure it's not even touching the obstacle at all? It's like we spent too much time on this. Love spending time on
Summarized conversation history. To ensure the avatar visually steps over the obstacle without touching it, you should increase the default value.
Okay, can we try the new values? Just change the code. It wouldn't work, would it?
Made changes. The default animation parameters have been updated. Step over knee boost, 1.2. Step over hip boost, 0.35. Step over root boost, 0.22. Knee lift, 0.8. Your avatar should now visualize.
Okay, it looks alright, but it's not great. Okay, yeah, we'll keep the changes, but it's not great. The avatar is still just walking through the obstacle. We want to avoid that.
To prevent the avatar from walking through the obstacle, you need to add collision logic that stops horizontal movement when the avatar would intersect the obstacle. Currently, the code only visually steps over but does not block movement.
Okay, can we do that? I mean, we can make the obstacle lower or something, like make it as a step. It's eventually meant to be walking up and down the steps and things like that.
Made changes. Collision detection has been added. The avatar will now be blocked from walking through the obstacle unless it is visually stepping over root Y above obstacle height. This prevents the avatar from passing through the obstacle and enforces realistic movement.
Yeah, the movement is not realistic at the moment. I don't know what's up. It still looks like it's just walking through it.
To make the movement realistic and ensure the avatar only crosses the obstacle when visually stepping over, the collision logic should check if the avatar is in a step-over state, i.e., root Y is above the obstacle, and only allow movement through the obstacle during that time. Otherwise, movement should be blocked.
Okay, can you update the code? Ooh, we're going places now.
Made changes.
Made changes.
The code is now updated. The avatar can only cross the obstacle when it is visually stepping over, root Y is high and in swing phase. Otherwise, movement is blocked and the avatar cannot walk through the obstacle. Reload the simulator to see the improved, more realistic behavior. Let me know if you need further adjustments.
Okay, so what's the point? Now it can't go over the obstacle at all. So it just gets stuck.
The avatar gets stuck because the step-over state, current root boost obstacle height asterisk 0.7 and swing phase, is
Okay, can we update the code, the values?
made changes.
Made changes.
Summarized conversation history. The collision logic is now updated. The avatar can cross the obstacle whenever its root Y, vertical boost, is high enough, regardless of swing phase. This should allow realistic step-over behavior without getting stuck. You can test the new movement and tune the boost values for natural animation. Let me know if you need further adjustments.
Okay, can you explain what's going on? So currently with the current step over root boost, we are not able to cross the obstacle. Now we are only able to seemingly cross it with a boost of 0.5, but then the avatar is getting stuck. Wait.
Here's what's happening in your current code. The avatar.
But after crossing, the avatar is getting stuck inside the obstacle. Here's what's happening.
Here's what's happening in your current code. The avatar can only cross the obstacle if its vertical root boost, current root boost, is high enough, specifically, greater than 70% of the obstacle's height. When the boost is set very high, e.g., 0.5, the avatar can clear the obstacle, but after
Okay, so the code needs to allow the avatar to finish crossing the obstacle even after the boost drops, so it doesn't get stuck inside. So can you fix the code accordingly?
made changes.
Made changes.
The code now tracks when the avatar enters the obstacle while stepping over, and allows it to exit freely even after the boost drops. This prevents the avatar from getting stuck inside the obstacle. Test the movement. The avatar should cross and exit obstacles smoothly, regardless of boost timing. Let me know if you need further tuning.
Yeah, it's actually working better for whatever reason. Yeah, this works much better. So that's great. Now, is there a problem with what happens if we approach the obstacle from like a different direction? This seemed to be a problem there, which is kind of looks like it's just crossing over.
Yes, there can be issues if the avatar approaches the obstacle from the side or at an angle. The current logic only checks if the avatar's root Y, vertical boost, is high enough to allow entry, regardless of approach direction. The boost is triggered when moving generally towards the obstacle, product greater than 0.7, but this is tuned for forward movement. If you approach from the side or at a shallow angle, the boost may not activate, so the avatar can't step over or gets blocked. To improve, the obstacle detection should trigger the boost for any direction where the avatar is moving into the obstacle's bounding box.
Yeah, can you update the code accordingly?
Made changes. The code now triggers the step-over boost whenever the avatar is about to enter the obstacle's bounding box from any direction, not just from the front. This should make crossing work naturally for side and angled approaches. Test the movement from different directions and let me know if you need further adjustments.
Yeah, it does work much better. For some reason I can't there was some problem. There are some issues. So it still looks like, wait, what's up with the
Great to hear the crossing works better now. If you're still experiencing issues, here are some common areas to check. Boost timing. If the vertical boost isn't triggered at the right moment, the avatar may not clear the obstacle or may get stuck. Edge cases. Approaching the obstacle very slowly, diagonally, or stopping inside the obstacle can sometimes cause unexpected behavior. Parameter tuning. The boost values and detection distance may need further adjustment for smoother animation and reliable crossing. If you describe the specific issue or scenario, I can help debug or refine the logic further. Just let me know what's not working as expected.
Hey, can you check and describe the image? And how do we make sure that doesn't happen anymore?
Summarized conversation history. The image shows the avatar standing on top of the obstacle, rather than stepping over it and continuing its walk. This usually happens when the collision or step over logic allows the avatar's root position, vertical height, to remain elevated while inside the obstacle, so the avatar lands and stands on the obstacle instead of crossing and returning to ground level. Why does this happen? The code currently sets a root. The image now shows the avatar standing inside the obstacle, rather than crossing over and returning to the ground. This happens because the avatar can stop moving while inside the obstacle, and the inside obstacle flag allows it to remain there, keeping its vertical boost. To prevent this, the avatar should not be allowed to stop inside the obstacle. If movement input stops while inside, the code should automatically move the avatar forward, or in the last direction, until it fully exits the obstacle. Once the avatar leaves the obstacle, reset the vertical boost in the inside obstacle flag. Made changes. The code is now updated so the avatar cannot stand still inside or on top of the obstacle. If movement input stops while inside, the avatar will automatically keep moving in the last direction until it fully exits the obstacle, then return to normal walking. This ensures the avatar always walks through and never gets made changes. The code now prevents the avatar from standing or walking inside the obstacle. If the avatar tries to move into the obstacle without visually stepping over, i.e., root Y is not above the obstacle, its position will be snapped to the nearest edge, blocking entry. The avatar can stand on top if it has stepped over, but cannot walk through or remain inside the obstacle. This ensures realistic behavior. The avatar is always next to made changes. The step over root boost slider now has a maximum value of 1.0 instead of 0.5, allowing you to set a much higher vertical lift for stepping over obstacles. This will help the avatar clear taller obstacles more realistically. Adjust the slider as needed for your simulation.
Is there something that keeps the step over root boost at the 0.5 maximum still? Because it doesn't seem to work when I'm setting it to, say, 0.85.
If you set the step over root boost slider to 0.85, but the avatar's vertical lift does not increase accordingly, it means the code is not using the updated slider value.
Okay, can you check the code? What? Hey, no, there's something wrong with the step over root boost slider. Can we check that the value is actually taken into account, is actually being used? It seemed to be still limiting the maximum at 0.5. So what's up with this sliding business?
Summarized conversation history. The slider for step over root boost is set with a max value of 1.0 in the HTML, and the event listener updates the global variable step underscore over underscore root underscore boost correctly. Made changes. A console log has been added to the animation loop. You will now see step underscore over underscore root underscore boost, current root boost, and root.position.y printed in the browser console each frame. This will help you verify if the slider value is being used and if there is any unexpected capping. Open the browser console while running the simulator and adjust the slider to observe the values in real time. Let me know if you notice anything unusual or need further debugging. Here's what's happening. Step underscore over underscore root underscore boost. 1 knee.
I need to adjust this smoothing. What? Okay, we'll have to continue this next time. I'll see you in a bit. Bye.